All right, I think we are live now. So let's get started, Naveen.
Yeah, sure.
Great. So good morning, everyone, and welcome back to AI Horizons, turning intelligence into impact, powered by AOlogic Technologies. I'm Jubin. I'll be your moderator for today's session. In our previous sessions, we have seen how AI is transforming creativity and decision making, but there's another field where AI is quietly making a game-changing advances, and that's computer vision. For decades, machines could only process numbers and text, but do not see or understand the way how humans do. Now that's changed. Today, with real-time object tracking and identification, businesses not only just capture video, they're extracting intelligence from it. So that's why our today's topic is computer vision for businesses, real-time object tracking and identification. Over next 30-35 minutes, we will be exploring why computer vision is becoming more critical driver of business outcomes, how real-time object tracking is reshaping industries like logistics, healthcare, and manufacturing, enterprises-ready solutions that are already giving ROI, the challenges leaders face in scaling vision systems and how to overcome them, and finally, what's next, how this field is evolving towards autonomous systems and smarter decision making. I'm today joined by Naveen Nautiyal, our department team lead at Aeologic. Naveen has been at the forefront of applying computer vision in enterprise solutions, from smart warehouses and automated quality checks to intelligent video analytics for business operations. Naveen, welcome. It's great to have you here.
Thanks, Jubin. Hi everyone. I'm really glad to be here. So, sharing what I have learned so far and to learn something from you guys also. So, today we will discuss about computer vision. So, imagine when you unlock your phone and it recognizes your face. That's computer vision. You post a photo and it automatically tags your friends. You drive a car and it detects pedestrian before you even notice them. So, this is what you have already seen, and this is what powered by computer vision. So basically, computer vision is giving eyes to your AI. It enables computer to see, understand, and make decision based on the images or videos which we provide. It's just like humans do. So in short form, you can say human vision is what your brain interrupts when you sees, and computer vision is what an algorithm interrupts when the camera sees. So what excites me most is that it's not just a lab technology anymore. It's solving real problems for businesses today. So whether it's tracking assets in a warehouse, monitoring safety on a factory floor, or even powering a smart retail experiences, the applications are endless. So I'm looking forward to share some practical insight with you all.
Great, great, Naveen. I think Naveen is already excited on a Saturday morning. All right, so let's start with the questions, right? From a leader's perspective, why should enterprises care about computer vision? What makes it a growth business lever and not just a tech experiment?
Okay, that's a good question. So computer vision turns passive video into an actionable data. That means higher efficiency, better accuracy, and it helps you make stronger decision. So for example, in logistics, it reduces manual errors by automating the tracking. In retail, it helps you understand the customer behavior in real time. For in manufacturing, it improves quality control also with 24/7 monitoring. And the ROI comes from reduced losses, faster processes, and safer operations. For leader, this isn't about fancy AI. It's about measuring impact on KPIs like efficiency, compliance, and revenue.
Great, great. I think that is the key, right?
Yes.
Compliance and revenue and KPIs. Definitely,
Yes.
those are factors that
Yes.
we need to consider. Cool. Moving towards the next one, right? Can you share some real-world examples of computer vision that are already driving results in business environments?
Yeah, sure. Although this word computer vision may sound like very futuristic, but the implementations are already going on. So I'll share some few real world examples with you. So imagine you have a warehouse where workers are loading some boxes on a truck. Like so, normally what would happen? There will be a guy who will count each box but that's a slow process. It's a tiring process. With computer vision, a camera can automatically count every box that passes through the loading area. So if one box is missed or an extra box is loaded, the system can alert the supervisor. So that's a one case. In a manufacturing plant, hundreds of product passes by a conveyor belt every minute, and a human cannot check every single item carefully. They might miss some tiny scratches or cracks or any defects. But a computer vision system can inspect each item automatically using a camera, and it compares the product images, what a perfect product should look like. So that helps in detecting the defects at early process. Also, it can help in monitoring the traffic. So in cities, cameras can help monitoring how many vehicles are waiting in a traffic signal. So if one side has heavy traffic and another side is empty, the signal can automatically adjust according to the what is needed at that point of time. Uh, you may have heard of this, the Amazon Go store. So they are using computer vision for automatic payment. So, for example, if you walk in and pick up a product, you just leave out this move out of the store, and the cameras powered by computer vision, they will recognize what item you have picked and they will charge directly from your account. So it's a hassle-free checkout. So it's not like that it's something new. These solutions are already implemented. They are working. So even in medical field, doctors are
Mhm.
now using computer visions to analyze the X-rays and MRI scans, because there are some very tiny defects, or you can say the things which a human cannot identify just by looking at an X-ray. So
Yeah,
these things are noticed by computer vision at a very accurate, you can say a very good accuracy. So
right.
these implementation are already happening right now.
Great, great. Yeah, definitely. I think some of these implementations are already, helping industries and businesses in
Yes.
reducing time and increasing the efficiency.
Yes.
Awesome. Let's move on to the next question, right? So, what are the challenges do enterprises face in implementing real-time vision systems, and how can they overcome them?
There are some big challenges. For example, the data quality. So the camera needs to be at the right position and the resolution. And you can also say scalability. The pilot work in one side, but scaling across 100 location is tough. And integration also. The vision system must connect with the ERP inventory or the security workflow for a better communication. Also, the cost and ROI clarity. Actually, a leader want to see the impact very fast. So the solution is phased adoption. So start with a focused high value case, and then integrate with existing system, define ROI upfront, and then scale gradually. So that's how enterprises move from a pool demo to a enterprise-wide impact.
Awesome. That's in a nutshell, that is the right correct use case and answer. So, my next question is regarding the governance and privacy, because AI and governance and privacy are something that
Yes.
is already discussed many times. So, with vision
Mhm.
systems monitoring people and processes, how do leaders balance innovation with privacy, compliance, and ethics?
Yeah, actually, it's a very important point that leaders should put safeguards like privacy by design. And, for example, blurring the faces when identity isn't needed, and storing what's actually required for compliances, and some cases like ensuring video intelligence is shared responsibly, and human oversight, especially in safety critical or HR sensitive context. So actually at A-Logic, we ensure every deployment respects compliance and brand trust, because adoption only works if stakeholders feels confident in the system, and they feel secure that their data is protected, and everything is seamless. These are the key points.
Definitely, definitely. I think, with AI and compliances, it is very important that these are closely integrated
Mhm.
and monitored. All right,
Yes.
so I think we are now at a stage where we can, do a quick demonstration. I think, Naveen, you have some demo that you can showcase to the
Yes, yes,
audience.
yes. Sure, sure. Although the word, I mean, it's kind when you listen the computer vision, it scares you. You think it's a scary thing, but I can show you a very simple demo to to make you comfortable with it. Let me share my screen. So is my screen visible?
Yeah, yeah, I can see your ID.
Okay. So I have a very basic demo. There's no rocket science behind it. So what this demo is doing, it will stream the video from your mobile camera to a server where the server will do some calculation on each frame and detect the object in front of your mobile camera. So it's a very simple pipeline. As you can see that this is a very simple Flutter code. Nothing much is happening here. We have this. We are first initiating the camera, and then we are creating a socket channel, and we are listening to this IP address. So basically, that Python server is running at my local. So I'm using this my local IP address, and that's the port number. And then we are just passing the JPEG bytes of the each frame. And as I'm using my local machine as server, so it doesn't have very high powered GPU, so I'm using CPU. So that's why if you see this, I have limited the frames to somewhere around 15 frames per second. How I'm doing this, I'm just creating an interval of 66 milliseconds. So basically, if you divide 1 second into 66 part, that will give you a 15. So that's roughly 15 frames per second, and
Hmm.
that's the Flutter end of code. And as you can see in for the detection part, I'm using this model. This is YOLO version 3. The full form of YOLO is you only look once. And the version 3 which I'm using, actually it's capable of detecting around 88 objects. And as you can see here, we are creating the WebSocket server, and that's the port we are using. And here you can see that we are loading our model, and we are using the CPU for the calculation, not the GPU. As I mentioned, I don't have very high-end GPU, so I don't
Right.
try my system. That's why I'm using 15 frames per second. And here's the detection part. So basically, we are creating a blob for each image frame, and then passing that blob to our model, which is loaded by actually OpenCV. So we are using OpenCV to run our model,
Hmm.
and this gives us the class. For example, it detects an object. It will give us the class of that object, what exactly the class it is, and the bounding box, the actually the coordinate of the bounding box, so that we can draw some overlay around it. And basically, if you see these two files, these wait and see configuration file,
Hmm.
these two works together to give you the class name and the coordinates. Actually, not the class name, but the class index. And this text file that has the name of each class at the index. So this is how it's working. So I'll now run this. So if you want to change like this, like I'm using my IP address. So if you want to run it even in your system, you can get your IP address. So yes, you can do if config, and you have to find something like this 192.168. That will give you your IP address of your local machine, and I'm using the correct one, I think. Zero. Okay, that's fine.
Hmm.
Now we will run our server. So as you can see that our server has started, and I've also connected my device so that you can see. Let me open this. Okay, so I've placed two object here. It's one water bottle and there's one cup here. As soon as I start stream,
Mhm.
uh, it will it will give you this window. That's So this is the output window from our Python code. As you can see, it has already detected the laptop and the accuracy it's showing it's around 99%. So it's
Right,
99% sure that it's a laptop. And
right,
if I move, I think it will detect, yeah, dining table, cup, you can see laptop. So and it's also giving the accuracy like the cup is 75, 80%. It keeps on doing detecting. So
right,
that's a basic example of how a computer vision works. And it's just a basic demo. You can extend it from here itself. So, for example, if you want to find, for example, you have a factory outlet of cups and you want your conveyor belt to have a process where it can detect defects in a cup while doing the packing and all those things. So you can place a camera with a good lighting that will capture each and every cup from different angles, and that can then cross check with the a perfect looking cup, and that can give you output like, okay, this cup is broken or this has scratch, it's not proper. So that's an extension of this. So
right, right.
I think
Uh, I would like to ask a few questions, right? So, you explained how the environment was set up, right? You mentioned you were using Flutter code as the client and Python code as the server, which was on your
mm,
local machine, and you used some
mm,
model, right? Let's try to dumb
yes,
it down and keep it in, explain it in more simple ways so that business leaders who are not technical, they are able to understand, right? So, let me ask a few questions, right? So, you have used a model that is processing the data, right? That is giving you the outputs.
yes,
Great.
yes,
And for client, which is what is client? Client is this system that we see, right? For that, you have
mm,
used a mobile application framework, Dart, Flutter, which will run on your
yes,
Android or iOS devices.
yes,
Right. And for server, you have selected your local machine because this is for just for a demo. But when we are
yes,
actually implementing it for a client, it will be
mm,
hosted on some server, some online
yes,
server which has configuration which has more GPU so that it can give
yes, yes,
good
exactly.
results.
Yes. And actually, it's not limited to the Flutter front-end mobile application. So let's suppose you already have some cameras installed at your factory outlet. So
Right.
what we can do is we can tune those cameras in a way that they can send those images to your server, and then we can do the processing. So that will reduce the cost of integration also. So it's not just about the Flutter front end. So
Right.
it's kind of universal. You can also use your system's webcam for this. So uh,
Right.
that's this. And like what I'm doing using my system as a server, you can do the same thing. Those are called edge server. For they actually they are industrial grade system which are called edge server. They
Mhm.
you can install multiple GPUs there for
Right.
heavy calculations. So it creates a complete local environment for you. So you don't have to depend on a cloud server or a remote server that can increase or add a delay, because you want everything to be snappy when you're
Right.
working on a live environment.
Got it. Got it. Yeah, I think that makes perfect sense now that, we have explained how the system works and we are able to classify the objects as well.
Yes.
All right. All right. Yeah, I think we can move with some of the questions, right? Naveen, if you are comfortable to answer, there are some questions coming in online. So, first
Mhm.
question is from someone named Reha. What is computer vision and how it is different from image processing?
Okay, I can give you example. For example, you have an image, right? And
Mhm.
let's suppose you are using OpenCV, and OpenCV can tell you that how many objects are there in a image. Okay, what it uh, what it does is it will convert your image to a grayscale image. Then it will detect the boundaries, and then it can identify that, for example, there are 10 objects in that image. So you can see that this is image processing. We are already doing this. So how it is different from computer vision is computer vision will tell you what object is that. It's not just about the count of objects. For example, the image processing will tell you these are 10 objects, but computer vision will tell you that these are, for example, four apples, two iPhones, two water bottles. So that's the difference between them.
Great, great, Naveen. Thank you for answering that. Uh, there is one more question that I would like to ask you. Uh, how is computer vision different from other AI technologies that are used in businesses?
Well, we have multiple, you can say AI domains and technologies.
Right.
So you can say that, for example, mm, there's a, for example, you are a service-based company, okay,
Mhm.
and you want a customer support uh, that works automatically or using the AI. So that will use AI agents. So what it will do is, for example, that will reduce the load on you, and the that AI model will answer the question of the user according to the business norms and what actually they provide. So these that's a separate you can say domain which doesn't
Right.
work with the images, or but it works with the database. And computer vision is something which works with visuals. You can say the images and videos, the frames. So that's the you can say the difference between uh, different types of AI domains.
Right, right. Thank you, Naveen, for answering those questions. So now I have like one final question for you, right? Looking
Sure.
ahead 2, 3 years, how do you see
Mhm.
computer vision evolving, and which industries will it benefit the most?
In the near future, computer vision won't just recognize object; it will understand the context also. So, retail stores, like I mentioned, the retail stores with no checkouts, that's already happening. That factories that will self-monitor quality in real time, they will identify the defects and monitor the quality. And cities that optimize traffic flow dynamically, and industries like logistic, healthcare, automobile industries. Uh, these will benefit the most. The winner will be the leader who start preparing today, because as you can see that how fast is AI maturing, and it's becoming the part of our life. With clean data integration strategies and trusted AI partners, computer vision is becoming a strategic differentiator, not just a tool.
Right, right, definitely. And you rightly said, if the leaders are starting early, they
Mhm.
have an
Yes,
mover's advantage. And you also mentioned about trusted AI partners. So I think I'll do a
yes,
shameless plug of Aologic here, right? So we will be
yes,
your trusted AI partners, definitely. So with the strength of AI development that we have, definitely in all the sectors that you discussed, Naveen, I think we will be able to help the leaders provide solutions around computer vision, right?
yeah, sure, Vivek, sure.
All right. I think it was a great session, Naveen. Thank you for those insights. And thank you to everyone who joined us this morning for the fourth edition of AI Horizons, turning intelligence into impact. So here's the key takeaway from today's discussion. Computer vision is not just about cameras. It's about intelligence in motion. From warehouses to hospitals to retail stores, real-time tracking and identification are turning everyday operations into sources of efficiency and growth. At Theologic, our mission is to help organizations adopt AI solutions responsibly and with measurable ROI, whether in vision, data, or automation. And this is only the beginning, right? We are in the coming sessions. We'll explore agentic AI, where AI not only sees and understands but acts on your behalf. AI in software engineering, where AI collaborates with developers to write and optimize production-ready code. So stay connected with us on LinkedIn and YouTube because if today was about AI seeing the world, the next session will be about AI shaping it. With this, Jabin signing off. Have a great day. See you in your next session. Thank you, everyone.
Thank you. Bye. Have a nice weekend.